Hi everyone. When wanting to quickly place many objects into a scene, a fairly common time-saving technique is to just let the physics system run wild for a couple of seconds and save the result. With the new Physics.Simulate function in Unity 2017, we can easily set up a tool to help us do this a little bit more efficiently. So the script we'll be creating will allow us to simulate and reset the position of our chosen objects, and we'll also be able to specify a force, say in a particular direction, and simulate that. Or let me do this, 90 degrees, and then they'll shoot off in that direction, or we can even randomize the force angle so that it gets scattered all over the place. That's the basic idea, so let's begin. I have a simple scene set up here in Unity with a basic terrain mesh with a mesh collider attached. Well, if you just want to use a default plane for testing, that will work as well. And then I've got a couple of cubes, some red, some blue, with box colliders and rigid bodies attached. So I'm then going to create a new C# script called Physics.Simulation. And I'll also create an empty game object with the same name. And I'll attach the script to that object and open the script up. This is going to have a public method called runSimulation. And inside here, we want to make a bunch of calls to Physics.Simulate, which takes in the time step, so we can just pass in time.fixedDeltaTime. Now, we don't know how many times we're going to need to call this for all of our objects to come to rest. So for now, let's just create a public int, max iterations, which I'll set to something big like 1,000. And we can just run a loop from 0 to max iterations and call simulate inside of that loop. Now, before we can take manual control of the physics, we have to turn off auto simulate. So we can say physics.autosimulation is equal to false. And we'll set that back to true once we're finished simulating with physics.autosimulation equals true. Now this should already work, we just need some way to call the runSimulation method from inside the editor. So I'm going to add a context menu attribute here. And once we've done that, can save and go into Unity. And on the physics simulation object, we can just go over to the gear icon of the physics simulation script, and the run simulation command should be there. So if we click on that, we'll see all of the objects have fallen into place. Now, most of the time, we're not going to need nearly 1,000 iterations for all of the objects to settle. So going back into the script, let's break out of this loop early if all of the rigid bodies in the scene are sleeping. So we'll first need an array of all of the rigid bodies. So I'll create a rigid body array called simulated bodies. And we can set this using find objects of type rigid body. All right. And then I'm going to add using the system.link namespace up at the top here. And this will let me say if simulated bodies.all. So I'm going to define a condition here, and if all of the simulated bodies meet that condition, then the all method will return true. So I'll start by defining a variable, rb for rigid body, and then using the lambda operator, I can create my condition, rigid body dot is sleeping. So only if all of the rigid bodies in the array are sleeping, will this return true, and in that case we can just break out of the loop. Now, just as a matter of interest, let's print out the value of I at that point so we can see how many iterations it is taking. So I'll go back into Unity, and all right, all of these are on the ground already, so I'll just raise them up again, and then come over here and run the simulation. And we can see in this case it took 101 iterations for all of the bodies to come to rest. Now, we do of course still need the max iterations, because you can imagine if one of the rigid bodies were to fall off the edge, then it would never go to sleep, in which case we don't want to have an infinite loop. So we still need to keep that max iterations termination condition as a sort of safety net. Alright, I'm quickly going to find that red cube that I dropped off the edge of the world and just bring that back up here. Alright. Now, I'd quite like to have the ability to, once I've run a simulation, to actually reset it in case I'm not happy with that simulation. So let's go back into the script. And in here, I'm going to define a new structure called simulated body. And this is going to hold a public read-only rigid body, just called rigid body. And then it will also have a read-only vector3 for the original position, a read-only quaternion for the original rotation, and a read-only transform for the transform component. Alright, and I'll press Command I to generate a constructor. This is going to just take in a rigid body in the constructor, and then it will go through and set transform equal to rigid body dot transform, and original position will be equal to rigid body dot position, and original rotation will be rigid body dot rotation. Alright, so this simulated bodies array is not going to be an array of rigid bodies anymore, but rather an array of simulated bodies. So of course we can't set this equal to find objects of type rigid body anymore, but once again link comes to the rescue, so we can just say dot select, and I'll create my rigid body variable followed by a fat arrow, and I'll be creating a new simulated body passing in the rigid body, and then we just need to convert this to an array. Now we have an error in this line because RB now refers to a simulated body, and simulated bodies don't have an isSleeping method. So let me rename this to body, and then I can just say body dot rigid body dot isSleeping. I'll then move the declaration of this array to outside of the method, like so, so that we can have access to it in this new method called reset all bodies. So this is going to say if the simulated bodies array is not null, then loop through all of the simulated bodies. So for each simulated body in the simulated bodies array, we're going to call body.reset, and that will be a method inside of the simulated body structure. So I'll create public void reset, and this is just going to say transform.position is equal to the original position, and transform.rotation is equal to the original rotation. A quick note from the future, as it were, the rigid body's velocity and angular velocity needs to be reset to vector 3.0 inside of the reset method. So I'll be adding that at the end of the video, but if you're following along, I recommend that you just go ahead and add that now. The code is on screen, just if rigid body not equal to null, then set both of those things to vector 3.0. If you're wondering why rigid body might be null, it won't at this point, but in a few minutes you'll see that we will be destroying rigid bodies in certain cases, and so hence the check. Alright, back to the present. So now, in order to call this reset all bodies method, let's add another context menu attribute. Let's call that reset. And now if we save that, let's quickly try this out. So I'll grab all of the cubes, move them up, and then I'll ask it to run the simulation. And okay, I don't like the configuration, so I will reset, and that seems to have worked. And then I can just quickly move some of these around, and try the simulation again. Okay, now imagine that these red cubes are the objects which we're trying to place, and these blue cubes are just other rigid bodies in our scene which we don't want to be affected by the simulation. So we need some way to tell which is which. So I think it makes sense for the physics simulation to only work on its child objects. So if we want to place the red cubes, we'll just put these all as children of the physics simulation. And let's go now into the script to set that up. So when we're running Physics.Simulate, there's no way to tell it which rigid bodies to simulate and which to leave alone. It's just going to simulate the entire physics environment. So the only thing we can do is simulate everything and then call reset on the ones which are not child objects. So I'm going to add a public read-only bool called isChild to the simulated body struct, and this will be set inside of the constructor. So bool isChild, and it can then say this .isChild is equal to the given isChild value. And when we're creating the new simulated bodies up here, we can pass in rigidbody.transform.isChild of this transform. Alright, then once we finish simulating, we can loop through each simulated body in the simulated bodies array, and we can say if that body is not a child, so let me preface that with an exclamation mark, if body.isChild is not true, then we're going to say body.reset. Now, just coming back to this condition over here, we're saying we can break out of the loop only if all of the rigid bodies are sleeping, but we don't care about the bodies which are not children because they're not going to keep their simulated position anyway. So we can just say or not body.isChild. So the logic is now we can break out of the loop as long as all of the rigid bodies which are children are sleeping. Alright, so let's save this and go into Unity. And once this is finished compiling, we can go run simulation, and only the red cubes have been placed. Okay, now you can imagine that for some of the objects that we're placing, we might want them to have a rigid body and collider attached because we want them to actually respond to physics during the game. But for some of the objects, we might only be adding the rigid body and collider for this placement process, and then we might want to remove those components afterwards because they're just static elements in the game world. So as an added convenience, at the start of the physics simulation, we can just look through each of the children, and for any which don't already have a rigid body and box collider attached, we can automatically add one, and at the end of the simulation, just remove those auto-generated components. So inside of the script, I'm going to create a list of rigid bodies. I'll call this the generated rigid bodies. And likewise, I'll create a list of colliders called the generated colliders. And then somewhere down here, I'm going to have a method called auto-generate-components. And this is going to start by saying generated rigid bodies is equal to new list of rigid bodies, and generated colliders is equal to a new list of colliders. And then it's going to loop through each of the child transforms of this transform. And it's going to say if that child does not have a rigid body component, then we can add one with child.gameObject.addComponent of type rigid body, and we can add that auto-generated component to the generated rigid bodies list just by enclosing all of this in generated rigid bodies dot add, like so. And I'm going to copy this and just paste it and replace rigid body with collider and generated rigid bodies with generated colliders. And instead of adding a rigid body here, we'll be adding a box collider as the default type of collider. And then we just want a method to remove auto-generated components. So here we can loop through each rigid body in the generated rigid bodies. And to remove it, we'll make a call to destroy immediate and pass in that rigid body. And then I'll just copy paste this for each collider, call that C, in the generated colliders. All right, we of course want to call auto-generate components at the very start of the simulation, and at the end we'll call remove auto-generated components. All right, so I'll save this and go into Unity, and on the third cube I'm going to remove the rigid body and the box collider, and on the second I'll just remove the rigid body, and on the first I'll leave the box collider and the rigid body. So hopefully the simulation will work correctly, and the components on each of the objects at the end of the simulation should be the same as it is now. So if we run the simulation, all of the objects have been correctly placed on the ground, and our first cube still has its two components, the second cube has just the box collider, and the third cube has neither box collider nor rigid body. So, success. Alright, the next thing I'd like to do is allow the user to specify a force that will be applied to each of these objects at the start of the simulation, just so that you can get some more interesting results. So opening up the script once more, I'll create a public vector2, and I'll call this force min-max. So the x-axis will be the min force, and the y-axis will be the max force, and we'll choose a random value between that. And let's also create a public float. I'll call this the force angle in degrees. So that will just be the angle around the y-axis that we'll be applying the force in. And then over here at the start of the simulation, we can go for each simulated body in the simulated bodies array. If that body is a child, then we'll want to generate a random force amount. I'll set that equal to random.range between force minmax.x and force minmax.y. And then vector3 force direction is going to be a new vector3. And because angles increase clockwise around the y-axis in Unity, we'll have mathf.sine of the force angle. And we of course need to multiply this by degrees to radians. And then on the z-axis, that will be mathf.cosine of force angle in degrees multiplied by degrees to radians. We can then say body.rigidbody.addForce, force direction multiplied by random force amount, and I'll set the force mode to impulse. Now, we might want to be able to randomize this force direction, so let's make a little bool here. Public bool randomize force angle, and over here we can say force angle is equal to, and if we're randomizing the force angle, then we will get random.range between 0 and 360. Otherwise, we will use the supplied force angle in degrees. And let's actually just go and multiply this all here by mathf.degrees to radians. And then we can replace all of this in here with force angle. Okay, now something that I forgot earlier is that in this reset method, beyond resetting the position and rotation of the transform, we also need to reset the velocity and angular velocity of the rigid body. So let's first check that the rigid body is not null. Remember that since we've got all that auto-generating and auto-removing of components going on, the rigid body might be null at this point, so we must check. And if it's not null, we'll say rigid body dot velocity is equal to vector 3.0, and rigid body dot angular velocity is also equal to vector 3.0. Alright, so we can now save this and go into Unity. And to test out this new force stuff, I'm going to hide the terrain. I think this will be better just on a regular plane. I'll reset that and scale it out a bit. And I'm going to include the blue cubes in the physics simulation now. And let's do this random force between, say, 10 and 15. And let's try run that. Alright, so they get scattered down there. I'll reset. And let's change this to 90 degrees. So when we run this, it should get scattered down in this direction. So that seems to be working nicely. And we can try randomizing the force angle. So I'll run it this time, and it gets scattered all over the place. So that is quite nice. And that is also everything that we'll be doing for the moment. So until next time, cheers.